Okay, so welcome into the second half of this double period, and today we're going to finish this off by using the famous quadratic formula. I love the quadratic formula, okay? For short, the quad formula, okay? So if you want to talk mathematics, you say, let's throw the quad formula at it. Right, so you've learned a number of methods to be able to solve a quadratic equation when it's equal to zero through the use of factorization and applying the null factor law. At times, you can also use inverse operations. Well, what if we had a quadratic that looks like this, ax squared plus bx plus c equals 0, and I wanted to solve for x. So if I solve for x, what would I get on this right-hand side? Because then I'd be able to quickly solve any equation in this form. Well, the answer to that is someone has done that for us, okay? So it's quite difficult, and it uses a complete the square on the general solution. You should look at it. It's in Cambridge as well. It's really impressive that they step you through it. So luckily someone has already found the general solution for us and called it the quadratic formula. But I have also called it the pulverizer. Yeah, I've heard it called that. Okay, so you throw things into the pulverizer and out pop the solutions. And so for any equation in the form ax squared plus bx plus c, the solutions for x are this. Okay, so you slam them into this. Now, we won't go into where it came from, but if you're interested, yeah, have a look at 5i and it will step you through it. What else to talk about? We give it to you, okay, so you don't need to remember it, okay? But I have seen, if you quickly Google quadratic formula tattoo, you'll see an overzealous mathematics student with a tattoo of the quadratic formula on the back of his or her neck. I don't know whether it's him or her, which is great and a great tribute to the quadratic formula, although if he, she ever needed it, it's on the back of their neck. So I'm not sure what the purpose is, but I digress. Okay, so solve the following using the quadratic formula. Okay, so basically the step-by-step process will go, you'll attempt to factorize this using the cross method and go for it on the null factor law. So you'd be like x, 1, no, it's not going to work. Right, so here is plan B time. Now you could complete the square, okay, and then use inverse operations or DOPS to solve it via the null factor law, but I can't stand doing that, okay? I can't stand using that method to do it, okay? So I use the quadratic formula, and I'll show you how both of them will work, and we're going to do a speed comparison, okay? So I'm going to do complete the square on it, and over here I'm going to do quad formula. Okay, so let's go complete the square first of all. Okay, so here it is. I'm going to go y equals, fence that off, and I've got x squared plus x plus, now half it, square it. So half of 1 is a half, squared is 1 on 2, all squared. Subtract it, which is a quarter, take away 6, which is 24 over 4. Okay. Now that's going to be y equals x plus a half, all squared, take away 25 over 4. All right, now what we're going to do to solve it is the x-intercepts occur when y is equal to 0. So let's replace y with 0. Okay, and then what we'll do is add 25 over 4 to both sides. I think this has got rational solutions. I actually think that this would have solved via the cross, which is fine. This is good. This is absolutely fine to see this happen. Right, so root both sides, plus or minus. So we can actually evaluate this one here. That's going to be plus or minus 5 on 2 equals x plus a half. Now, what we'll do then is say that x is equal to, now we've got 5 on 2 take a half, and x is equal to 5 on 2, or negative 5 on 2 plus, whoa, what have I done there? Negative 5 on 2 take a half, and x equals 4 on 2, which equals 2. X equals -6 on 2, which equals -3. Right, so this is a solution that's got rational solutions. So again, I'll just show you what's happened there. I've misread the problem and I've just assumed that because it's asking me to use the quadratic formula that it couldn't be solved on the cross, but this one absolutely can. 3, 2, and that's negative. X plus 3, x take 2 equals 0, which means x is equal to -3 and x is equal to 2. So we got both of those via the complete the square process. Now, that's pretty easy to do it that way, obviously. This is the harder way to do it, but you can also use the quadratic formula if it's got solutions. So we're going to just demonstrate this on the quadratic formula. Now, you may think, why is he doing this when it's got the cross will do it? Just go with me. Let's just do one and see what you think. All right, so the quadratic formula needs the trinomial written in ax squared plus bx plus c form. So that's got to be the form ax squared plus bx plus c. Now we note that the quadratic formula has b's in it, and a's in it, and c's in it. Okay, so we want to get these a value, b value, and c value, and I recommend writing them down. So a value is the coefficient of the squared term, which is 1. The b value is the coefficient of the x term, which is also 1. The c value is the constant, that's -6. All right, so let's run the quadratic formula. We say x is equal to, okay, then we do negative b, that's -1, plus or minus the square root of b squared, which is 1, take away 4 times a times 6. Okay, so that is all going to be over 2a, which is 2. X is equal to -1 plus or minus. Okay, we've got 4 times 1 is 4. 4 times -6 is -24. We're going to subtract -24 is 25. That's root 25 on 2. That's x equals -1 plus or minus 5 on 2. All right, let's just try both of the solutions or split the solutions. We've got -1 plus 5 is 4. 4 on 2 is equal to 2. X is equal to -1 take 5, which is -6 on 2 is -3. All right, so what's the preferred method? Well, number one, it's the cross. Okay, but have a look how much less working out there is with the quadratic formula as opposed to the complete the square process. Okay, so this is a winner if it can't be solved on the cross, in my opinion anyway. Okay, now, did you notice part of the quadratic formula which determined the number of solutions you were able to find? Well, it's a thing we call the discriminant, okay? So this thing here helps us work out how many solutions we've got, okay? Now, if this thing here, b squared take 4ac, works out to be less than 0, that turns out to be less than 0, then what happens is we're going to attempt to square root a negative number, and you actually can't square root a negative number. I'll show you. Non-real in calc, okay? Because remember, that's asking you to find a number that when multiplied by itself equals -9, and when I multiply numbers by themselves, they always come out positive, so this just doesn't work, it doesn't make sense. All right, when it's equal to 0, what happens is we've got one solution, okay? And when it's greater than 0, we're going to get two solutions because we get plus or minus this amount here. So let's go down and just note that the discriminant is equal to, so if that's our quadratic formula, the discriminant is b squared take 4ac. When the discriminant is less than 0, the quadratic has 0 real solutions because you cannot square root a negative number. And just a little disclaimer on that, if I go into the complex number system and pose the question again, I can do that. And that is because in specialist maths, they've introduced a situation where you can square root a negative number, okay? And they call that the imaginary number system. But here in Year 10 Maths, or in Maths Methods anyway, we work in the real number system, which says that there's no such thing as an imaginary number. Okay, so we are going to work with that. When the discriminant is equal to 0, the quadratic has one real solution. Okay, and the solution will be x equals, what's supposed to go there? It's x equals negative b over 2a, because what happens is that becomes 0, so it gives us one solution only. So that's going to be x is equal to negative b over 2a, because I'm going to use some bad mathematics language here and say, because the square root of 0, that is equal to 0, so it disappears. It doesn't really disappear, it just, like, we don't write it. We don't put it down because, like, again, I'm 42, but I don't write it as 42 plus 0, okay? That can kind of disappear. All right, when the discriminant is larger than 0, the quadratic has two real solutions because the square root of a pos will have a plus or minus solution, okay? So you'll get two different variations on this, so we'll get split solutions. All right, so let's determine the number of solutions for the following quadratic equations. All right, so remember, we can determine the number of solutions by using the discriminant, which is that thing there. It's part of the quadratic formula, this thing here. So let's note that we've got an a value of 5, a b value of -7, and a c value of -2. Where did I get those numbers from? It's from the general form 0 equals ax squared plus bx plus c. There's a, there's b, there's c, there's a, there's b, and there's c. All right, let's use the discriminant. So b squared is -7 all squared, which is 49, take away 4 times a, which is 5, times c, which is -2. Discriminant is 49. Now that's 20. 20 times 2 is 40. That's -40. So that's going to be plus 40 because we subtract the negative. That's going to be discriminant is 89. Now that is a discriminant that's larger than 0. So we're going to say discriminant greater than 0, therefore 2 solutions. Okay, let's have a look at this one. Now we can't say what use the discriminant just yet because it's not in the form ax squared plus bx plus c. So let's quickly change this to 4x squared, take 12x plus 9 equals 0. So what I've done is subtracted 12x. Let's note our value of a is 4, b is -12, and c is equal to 9. All right, let's go. Discriminant equals b squared, which is 144. Take away 4 times a, which is 4, times c, which is 9. Okay, 9 fours are 36. 4 times 36 is actually going to be 144. So the discriminant is equal to 0. Okay, so in conclusion, discriminant equals 0, therefore 1 solution. Okay, this one here, and I'll try to just explain what the 1 solution thing means by going to graph and table. Let's just graph that function. 4x squared, take 12x plus 9. Okay, you can see there that it turns on the x-axis. Let's do this one here and have a look at that, and we should get 2 solutions or 2 x-intercepts. 5x squared, take 7x, take 2. Yeah, graph it for me. Yep, there's the 2 solutions. All right, let's see what happens with this one. I've got a sneaking feeling this one doesn't have any solutions. So it's in the ax squared plus bx plus c form. So we're going to go a equals 1, b equals 1, c equals 8. Discriminant equals, okay, we've got b squared, which is 1, take away 4 times 1 times 8. Discriminant is equal to 1 take away 32. Discriminant equals -31. I'm going to say discriminant is less than 0, therefore 0 solutions. Again, useful to graph that and see what that means in terms of the picture. X squared plus X plus 8. Let's have a look. Where is it? Where are you? Ah, there you are. All right, so there's the x-axis here. I want to know how many times it intersects the x-axis, and this is saying it doesn't. And the discriminant is telling us that by saying I'm less than 0, so I've got no solutions. Right, this last one here, we go 5x squared, take 4x, take 7 equals 0. Okay, we want to put that in the ax squared plus bx plus c form. Right, note our a value is 5, b value -4, c value -7. Discriminant equals b squared, 16, take away 4 times a times -7. Okay, I got a good feeling about this one. 16 take away, this is going to be add 20 times 7, 7 times 20, 140, 20. Mental blank for a sec there. Discriminant equals 156. Discriminant is larger than 0, therefore 2 sols. Okay, so just some examples on the quadratic formula now. Okay, so let's actually find the solutions to these, and don't forget to have that nearby so that you can look it up when you need it. Okay, again, you don't have to use the quadratic formula. You can solve this using complete the square, but if you do, my hat's off to you, because I can't stand using it. Okay, it just takes about 15 more steps. Right, so this one here, we're going to note our a value is 1, b value is 5, c value 6. Right, let's pop this all into the quadratic formula. In fact, should we do, no, let's just put it in the quadratic formula. X equals, so we've got negative b plus or minus the square root of b squared, 25, take away 4 times 1 times 6. Okay, that's x is equal to, I forgot to put it over 2a, which is 2. That's -5 plus or minus square root of, now that's 25 take away, that's 6 fours are 24, we're left with 1 over 2. X is equal to, now the square root of 1 is just 1, so we're going to say -5 plus or minus 1 over 2. What are our solutions? X is equal to -5 plus 1, which is -4 over 2 is -2. X is equal to -5 take 1, which is -6. -6 over 2 is -3. Feels like we've just done that one before, but all right. So because we got these rational solutions here, that means that I actually didn't need to use the quadratic formula. This could have been done using the cross, and it would have happened much quicker, but it just goes to show that we can do any of the problems that have x-intercepts with the quadratic formula, that if I stuff up the cross and think that it can't factorize using the cross, I can throw it in the quadratic formula into the pulverizer, this thing here, and out pops, from the pulverizer, out pops the 2 solutions. Okay, let's go for it on this one. A equals 1, B equals 5, C equals -3. A reminder, I'm getting those values from y equals ax squared plus bx plus c, that form, B and C. All right, x equals -b, that's -5, plus or minus the square root of b squared, 25, take 4 times 1 times -3, all over 2 times the a value, which is that. X equals -5 plus or minus. Right, so this is going to be 4 times 1 is 4, 4 threes are 12, -12. That's going to be 25, 35, 37 on 2. Right, and there's nothing else we can do with that. That's the answer, and we've got it in one step. Well, 1, 2, 3 steps. Okay, now again, you guys who want to stay loyal to complete the square, be my guest, complete the square on that thing there, and see you in about 15 minutes. All right, 2 more examples. Okay, remember that when we want to use the quadratic formula, it needs to be in the form 0 equals ax squared plus bx plus c. This isn't, so let's quickly manipulate it. X squared plus 6x plus 9 equals 0. Now, I've got the sneaking suspicion this one works on the cross. So let's try it. X 3 plus, it's x plus 3, x plus 3, b equals 0, x is equal to -3. It's going to have one solution. Now just pretend I thought I'll use the cross on that and I couldn't work it out. So I go, all right, I'm going to throw it into the quadratic formula. Okay, so let's do it anyway. So I know the solution is x is equal to -3, but I'm curious to see what the quadratic formula says. A equals 1, b equals 6, c equals +9. X equals, okay, so it's going to be -b. So I remember the quadratic formula, but you guys don't have to memorize it. You just need to be able to use it. So it's -b, which is -6, plus or minus the square root of b squared, 36, take away 4 times 1 times 9, all over 2a, which is 2. X is equal to -6 plus or minus. Now, that's going to be 9 times 1 is 9, 9 fours are 36. That's the square root of 0 over 2. X is equal to, now the square root of 0 is just 0, so it's plus or minus nothing. So we just write it as -6 on 2, which is equal to -3. So there is our solution that we get via the quadratic formula. Okay, this last one is pretty nasty. Okay, so again, if you want to complete the square on that thing there, be my guest, but I'm just going to slam this straight into the quadratic formula. A equals 2, b equals -3, c equals 4. All right, so let's slam it in. X equals -b, so -3 is going to be 3, plus or minus the square root of b squared, that's -3 all squared, which is 9. Take away 4 times 2 times 4. Nine take away b squared, take away 4 times the a value times the c value. Okay, all over 2a, which is 4. X is equal to 3 plus or minus 9 takeaways, so that's 16. 16 times 2 is 32. 9 take away 32. X equals 3 plus or minus the square root of. Now that's going to be 9 removed from 32, -22, -23 over 4. So are they our 2 solutions? Let's just see what happens when I graph this thing. Did it again. All right, so it seems to suggest here that it doesn't have any x-intercepts, but we have used the quadratic formula to get the x-intercepts. So that's a little bit of an awkward situation. I've got x-intercepts, but the parabola says I don't have any x-intercepts. Now what's going on here? Well, actually, it's got to do with this part here, which again is the discriminant component. So what I've assumed is that it did have solutions, in which case I've popped it in, okay? But we're going to say that root -23 is not real, therefore no solutions. Okay, so this part here, we can't square root -23, it doesn't exist. So we're going to conclude that this one here has actually got no solutions. So I suppose the moral of the story is the quadratic formula won't solve everything. It won't find x-intercepts when a parabola doesn't have x-intercepts. So the quadratic formula hits back by trying to square root a negative number and saying, you can't do this, you can't do this. And it's telling you, I don't have any x-intercepts. All right, so there's the work for the second half of the period there, girls, 5i.